math educator, and I hope to make this topic easy for you. So do let me know if I can help you in any way, and you can always get back to me for any help. Now, given this matrix, this is a determinant. A determinant is a 2 by 2 determinant of second order. You have 2 rows and 2 columns, and as you know, you expand it as a1 b2 minus a2 b1. Then this is a third order determinant. We have 3 rows and 3 columns. And now what is cofactor of, if I take an element say aij? It is minus 1 raised to I plus j, determinant obtained by deleting the ith row and the jth column. And we denote it by capital Aij. Now capital A1 is the cofactor of A1. So in general we denote cofactor of A1 by capital A1. What will be cofactor of B1? Capital B1. And Laplace's expansion. In Laplace's expansion, a determinant can be expanded by any row or column. So if I take the first row column here, I can write this as A1 capital A1 plus A2 capital A2 plus A3 capital A3. Now if the elements of any row or column are multiplied by the cofactors of any other row or column, then delta equal to 0, or the value of the determinant equal to 0. So for example, if I write A1 into capital B1 plus A2 into capital B2 plus A3 into capital B3 is 0, we are multiplying A1, A2, A3 by the cofactors of another column. So this becomes 0. Now coming to some basic terms, a square matrix, all of whose elements below the leading diagonal is 0, is called an upper triangular matrix. So you can see here, all the elements below the leading diagonal is 0. A square matrix, all of whose elements above the leading diagonal is 0, is called a lower triangular matrix. So here it's a lower triangular matrix because in the top everything is 0. Now if we have to express this matrix, 3, 5, minus 7, minus 8, 11, 4, 13, minus 4, 6, as the sum of a lower triangular matrix and an upper triangular matrix with 0 as the leading diagonal. Now upper triangular matrix has to have 0 as the leading diagonal. So this is the lower triangular matrix and this is the upper triangular matrix with 0 as the leading diagonal. So if I add this, I get A, X, Y, D, B, Z, E, F, C equal to this matrix on the left. Equating, we get the values of A, X, Y, D, B, Z, E, F, C. Substitute here. So we have written it as the sum of a upper triangular matrix and a lower triangular matrix. Coming to some more definitions. Two matrices A and B can be multiplied if the number of columns of the first matrix equal to number of rows of the second matrix. If two matrices can be multiplied, they are said to be conformable. And if A squared equal to A, matrix A is said to be idempotent. A matrix A is said to be singular if determinant A equal to 0. So we'll do a small problem for what values of X is this matrix singular. So because it is singular, this 3 by 3 determinant will be 0. So I write 3 minus x2, 2, 4 minus x1, minus 2 minus 4 minus 1 minus x equal to 0. Now if I were to apply the transformation R1 plus R2 plus R3, this would reduce to 3 minus x, 2 minus x, 2 minus x, 2, 4 minus x1, minus 2 minus 4 minus 1 minus x equal to 0. Now if I were to do R2 plus R3, again there is no hard and fast rule. You are free to use your own row or column transformation. I am just trying to simplify this because expanding this becomes difficult. So that would reduce to 3 minus x, the first row remains the same, and the second row would be 0 minus x, minus 2 minus 4 minus 1 minus x equal to 0. Now if I were to do C2 minus C3, this would reduce to 3 minus x, 0, 2 minus x, 0, 0 minus x, minus 2 minus 3 plus x, minus 1 minus x equal to 0, And now if I were to expand this, so now I'm going to expand by the second column. So if I expand by the second column, this reduces to minus of minus 3 plus x, because you know there's alternate plus and minus, so plus minus plus minus plus minus plus minus. Determinant 3 minus x, 2 minus x, 0 minus x equal to 0. So you get minus of, when you expand, minus 5 minus x, 3 minus x into minus x equal to 0. So your values will be ultimately x equal to 0 or 3. This is actually minus 3 minus x, minus 3 plus x. So this is what you will get. The value of x would be 0 or 3. Now for any given matrix A, the matrix obtained by interchanging the